In this video, you're going to learn how to use dimensional analysis by putting all those baby steps together. We've been working on baby steps 1 through 5, getting all those skills that you learned earlier ready to assemble and completely work dimensional analysis problems. But first, you might want to know, what is dimensional analysis? It's how we would convert between units of measurement. So for example, if we had dollars and we wanted to convert that to pesos, we would use dimensional analysis for that. Or if we knew something's weight in pounds and we wanted to know what it was in kilograms, then we would use dimensional analysis for that. It's going to be the same information, it's just a different perspective, like a different country or a different system of measurement. And the way we know we can use dimensional analysis for this instead of having to use algebra or something is because the way they're related is by ratios. There's a ratio of how many dollars there are to a certain number of pesos, and there's a ratio of pounds to kilograms. So here's an example problem where we would use dimensional analysis. On average, an atom of gold has a mass of 197 AMUs, which means atomic mass units. So we would like to know how much would 1 million atoms of gold weigh in pounds. And for 1 million, we're going to use 1.00 times 10 to the 6th atoms so that I can have 3 significant figures here. So the first thing we would do is called the setup, and that's what baby step 5 was teaching you, is that we can start this problem by saying, I'm trying to find, so question mark, the weight in pounds, and the abbreviation for pounds is LB. So what is the weight in pounds? Then put our equal sign, and we're given this amount of 1 million, or 1.00 times 10 to the 6th atoms of gold. This part right here, where we just took the word problem and turned it into a question mark, an equal sign, and the given amount, it's called the setup. Since I know these are related by ratios, I'm going to draw a really big numerator-denominator line. My first conversion factor that I'm going to use needs to have atoms of gold in it, because I need something on top to cancel something on bottom. So if I look in the problem, they told me that an atom of gold has a mass of 197 atomic mass units. So I could put the information about 1 atom of gold in the denominator and the 197 atomic mass units in the numerator. That lets atoms of gold and atoms of gold divide out because one's in the numerator and one's in the denominator. So that would be our first conversion factor. So then we're ready for our second conversion factor, where we would like to get from atomic mass units to pounds, which is what they asked us for. They didn't give us that in the problem, so we would have to consult some sort of a chart for that. So here's a little chart that tells us that 1 pound is 2.73 times 10 to the 26th atomic mass units. So I would get my parentheses ready, and I see that I have AMU in the numerator, so this part right here would have to go in the denominator to be opposite. So 2.73 times 10 to the 26th atomic mass units and 1 pound. That would let AMU and AMU divide out and cancel. So the next thing I would do is I would figure out, how do I put this into the calculator? Well, this is in scientific notation, so I would enter it as 1.00, use that E button, 1E shows up on the screen, and then just type in the exponent 6. Then I need to multiply that by 197. And then the next number over is a 1, and then units of pounds. So I know these are going to go on my answer, and I don't have to multiply by 1. The only other number is in the denominator. And baby step number 2 tells us if a number's in the denominator, we have to divide by it. So that would be 2.73, use that EE button again, exponent is 26. So we put everything into the calculator. Let's pull the calculator up and do that. So we need to turn the calculator on. And it would be 1.00. On this one I have to hit second and the comma to make the E show up, and then the 6, multiply by 197, and then divide by 2.73, second, and hit that EE button again, 26. I hit enter, and I get a whole bunch of calculator garbage, and then an E negative 19. So that tells me my answer is going to be times 10 to the negative 19th, but then I have to round this to those 3 significant figures I can have. So that's my first sig fig, second sig fig. This 1 is my third significant figure. Because what's next door is a 6, I'm going to round up and call this 7.22 times 10 to the negative 19th. So my answer, rounded, would be 7.22 times 10 to the negative 19th. And then I also need units. So that's where my pounds come in. Every other unit was canceled out except for pounds. So my final answer would be 7.22 times 10 to the negative 19th pounds.